At the University of Arizona Bio5 Institute, we bring together hundreds of multifaceted experts that include world-class bioscientists, engineers, physicians, and computational researchers. This team science approach is designed to ignite creative solutions to the many complex biological challenges facing our families and communities, and has resulted in disease prevention strategies, promising new therapies, innovative diagnostics and devices, and improved food sustainability.
Hello, and welcome to another episode of Science Talks, a conversation hosted by the University of Arizona's Bio5 Institute. My name is Lisa Romero. With stress being a constant factor in the daily lives of many, we need to ask ourselves if there are greater health risks affecting us when feeling overwhelmed. To answer this question, scientists have investigated mind-body connections to better understand ourselves and related diseases. Today, we're joined by physician scientist and Bio5 member, Esther Sternberg. Dr. Sternberg is a professor of medicine, the research director of the Andrew Wiles Center for Integrative Medicine, and director of the University of Arizona's Institute on Place, Wellbeing, and Performance. She is recognized by the National Library of Medicine as one of 339 influential women who changed the face of medicine. Internationally recognized for her discoveries in the science of the mind-body interaction in illness and healing, Dr. Sternberg is a major force in collaborative initiatives on mind-body, stress, wellness, and environment interrelationships. Thank you for your time, Dr. Sternberg.
Well, thank you.
In all of that.
Thank you for that wonderful introduction. I really appreciate it.
Yeah, and I think the most special of all of that is that we get to have you here at the University of Arizona, and how you bless the university, but bless our community and our state, and you represent us within all of that. And I know that you've been able to carve out a really special place. I will say that word right now, but at the university, and really bring your mission of education and research and learning and everything to this next generation as well. And so that's really special. But I think before we get into all of that, and I want to get into all of that, one of the things I like to put everybody on the spot. First thing I like to ask in these podcasts is, if I asked you in one word to describe what science is to you, what would that look like?
Curiosity.
Yeah, that's a great one. I'm assuming that fuels you on even the days when science doesn't feel great.
My father used to say, my father was a scientist, and he used to say that curiosity is a disease, and you just can't get over it, and it drives you, and it's a need, like trying to figure out how things work and why things are, and of course the fact that in the process of figuring it out, you're helping maybe millions of people in many different ways. That's really where it's all about,
I think you, started to weave your father into this. And I really wanted to ask you, sort of what was your original inspirations for your work today in the areas of integrative health and the intersection of the built environment?
Well, if I go back to childhood, my father was a professor at the University of Montreal in the same department as Hans Selye, who coined the word stress. So as a child, my sister and I used to play in my father's lab, and we would see Hans Selye with his sort of like gaggle of student geese walking behind him in the hallways. And he was quite intimidating, although as an adult, I knew he was not so tall, but he was a very intimidating figure. And in that time, that was in the 1950s, Hans Selye was viewed with a lot of skepticism and concern because he went around the world proselytizing this concept of stress. He got the word stress into every language in the world. And so that actually did not inspire me. That knowing that he was viewed with skepticism by his colleagues made me distance myself from this field of stress, because, stress that's sort of a fringe idea. But I loved biology. As a high school student, I loved biology. And this is for the students, if you don't know what you want to do with your careers and you're sort of grappling with what you do want to do and you don't want to do. I did not want to go into medicine, even though my father was a physician and a professor of medicine. But my high school guidance counselor encouraged me to apply to McGill University's 7-year medical program. And I said, but I don't want to go into medicine. And he said, well, that's okay, because you just do the same first 3 years in your bachelor's and your undergraduate degree, and you have 3 years to make up your mind. And if at the end of 3 years you don't want to go into medicine, then you finish your bachelor's and you're done. And if you do want to go into medicine, then you're all set. At the end of 3 years as an undergraduate, I discovered that I loved medicine. I loved the scholarly part of medicine. I loved the idea of working with people. I loved the idea of helping people. And, I volunteered in the hospital. I got to know how it was to work with patients. And I also worked in my father's lab over the summer, and I just had a ball. I just loved working in the lab. It was amazing to me when the idea that, of course, my father had the idea, I didn't have the idea, but he told me how to go about testing an experiment, and to see that it actually worked and to see the results, it was just mind-boggling. And so, yes, I fell in love with the idea of research and taking care of patients. And then I had my aunt, it was also a professor of physiology. She still is a professor of physiology at McGill University. And so I had that role model of a woman who could be a professional in the biomedical sciences. And so all of that helped to shape my my youth and my evolution.
That's really interesting. And I really love that you gave sort of a shout out to students about, your path is not necessarily linear. Your decision making in one moment doesn't necessarily reflect where you will end up, because I think, we hear so many students struggling with that. And I think we all did at a certain point, and you think, every decision you make is the last one you're going to make, and it never is.
And you said that your path is not necessarily linear. It's never linear.
Yeah.
Don't even think about it being linear.
Yeah.
In everything I've done in my entire career, I don't end up doing what I thought I was set out to do at the beginning. Mm-hmm. And it's kind of, you can think about it as, rowing across a river that has a very strong current, and you want to get from point A to point B, and the current keeps pushing you in different directions, and you have to keep correcting course in order to get to point B. But maybe you decide you don't want to go to point B. Maybe you want to go to point C, and that's a big discovery, and that's wonderful. So really, students should keep that in mind. And also, it's really important. One thing I learned in my early career as a postdoctoral fellow, where I was working on a project that was really a brilliant idea. My supervisor had this really brilliant idea. And it took me 2 years to figure out it wasn't going to work. The chemistry didn't work with the biology. And I was devastated. I was crying. And I was in St. Louis at the time at Washington University in St. Louis. And a former mentor had come through. He was speaking at the university. And I just sat down in the cafeteria and cried. I'm failing. And he told me the most important piece of wisdom in my life, in my career, which is that we need the luxury to fail, because it's from our failures that we learn better. And he said, if you were just churning out papers, dozens of papers, using some kit you're not learning how to do research. You're learning how to do research. These 2 years taught you how to really do research. And it's painful because it feels like a failure. It is a failure, but it teaches you how to go forward. And I think it was Eleanor Roosevelt who said that you only fail when you give up. So you just keep on trying new approaches, and success is not how many times you succeed, but how many times you turn a failure into a success. That's what success is.
Yeah, I love that. I give a similar talk to we have a high school research internship program, as I think you're aware, our Keys program, and I give that same talk every year because, and the interesting part of that, and I mean, you alluded to this, but is that even with those failures and those non-linear things that happen during the course of your journey, it's really interesting when you look back at my age, or, a little bit further down the path, when you have some perspective, you have the luxury, and you said this word too, the luxury of some perspective, that everything ended up how it was supposed to. Like, yes. even the steps that you thought were completely unrelated to anything you would ever want to do, or you had to take a job because you needed the money or because you didn't know what else to do at that moment, they end up being building blocks. And yes. I love how you articulated that. It's really important, I think. So yeah. So fast forward to today, you are a pioneer in this really incredibly evolved thinking of the science of this mind-body interaction and illness and healing, how the role of our built environment, our place, contributes to well-being. But talk to us a little bit about how you got there. You talked about your beginnings and how you sort of came into really loving medicine and research, but then talk about from that point to this one, what makes you passionate about this area?
Well, it all started with a single patient. I was finishing up my rheumatology fellowship training at McGill University, and I was called to see a patient at the Montreal Neurological Institute on Christmas Eve, 4:00 Christmas Eve. And talk about not wanting to do something. And that was I was planning to go on a ski vacation. But I went to see the patient, and the reason it was an emergency consult was that the neurosurgeons, neurologists wanted to send the patient home for Christmas the next day. But he had developed an autoimmune scarring disease while receiving an experimental treatment for his fatal form of epilepsy. It was intention myoclonus. Every time he tried to do something, he would start to have he tried to drink a glass of water and he'd start to have an epileptic fit. And so they were giving him a drug which changed brain serotonin. It was before the time of SSRIs, and the idea was to increase brain serotonin because this form of epilepsy was thought to be related to too little serotonin. So they wanted to know if it was safe to send him home and what we should do, and whether this autoimmune inflammatory disease was related to the drug they were giving him. That image of that man in bed, I came to the door of the room. The light was fading. It was 4:00 in the afternoon, and the winter in Montreal, it gets dark already then. And the sheets were tented up over his legs. It was so painful, he couldn't bear for the sheets to touch his legs. His arms were flexed. He couldn't fully extend his arms because they were so scarred. He looked like he'd been in a 3rd-degree burns all over his body. And I was convinced that from that case onwards, that the brain has something to do with the immune system. Now, that was in 1978, 79. And at that time, the fields of neuroscience and immunology did not believe that the brain and the immune system talked to each other, communicated. There was this thing called the blood-brain barrier, where immunologists said, well, immune molecules are so big, they can't get across the blood-brain barrier. And neuroscientists said, well, the brain's, the neurotransmitters don't do anything to the immune system. Well, we know now that that's all wrong, but back then, it just wasn't believed. The idea of the mind-body connection was considered so fringe that it was dismissed. People who were doing research on this were dismissed. But I was convinced by that single patient. So that changed my career. Instead of going back into clinical practice, which I loved, I had been in family practice for 2 years before I went back and trained as a rheumatologist. And I really wanted to do that. I wanted to go back and be the rheumatologist in the clinic in Montreal where I had worked. But we talked earlier about curiosity being a disease. I was so wrapped up in the search to try to understand how could it be that giving a drug that changed brain serotonin could trigger this disease. And I realized in looking at the literature that nobody had done these kinds of studies, and I needed to do it myself. And so that led me to start looking at the effects of neurotransmitters on immune cells. So I went to to Washington University in St. Louis, and there I was sprinkling serotonin and other neurotransmitters on macrophages in culture. And I love to watch these little macrophages gobble up plastic beads. I felt like a farmer, and I could see with my own eyes that when you put serotonin on top of these macrophages, they started just gobbling more beads. It activated those immune cells. And then I moved to the National Institutes of Health, to the intramural research program, where I realized that no end of, so I published a couple of papers in the Journal of Immunology on serotonin and macrophage activation, but I realized that no end of in vitro studies is going to prove how the brain and the immune system communicate. You've got to have the brain attached to the immune system in order to understand that. So I started doing animal studies in rats, in 2 different strains of rats that had been inbred strains of rats, one that was highly susceptible to a whole host of autoimmune inflammatory diseases, the pattern of which depended on the antigen to which they were exposed. If you gave them bits and pieces of streptococcal cell walls or other bacteria, if you gave them, they got something that looked like rheumatoid arthritis. If you gave them ground up thyroid, they got thyroiditis, and ground up spinal cord, they got something that looked like multiple sclerosis, EAE. And so they were highly susceptible to all these autoimmune inflammatory diseases. And yet their cousins, the Fisher rats, were highly resistant to exactly the same antigens, and they didn't get sick. So I used those 2 strains of rats. And here's another example of what I thought was a failure, but turned out to be the real insight. Sometimes when experiments go exactly in the opposite direction than you think they should go, that's the most important insight, and tells you really what's going on. If the experiment does what you think it should do, then you haven't really learned anything, right? You've predicted it and it's correct. So we started giving them a drug that blocked brain serotonin, and I thought this would be the next great anti-inflammatory drug. And on the second dose of the drug, we decided we had to give the drug every 12 hours for 8 weeks. So, this was not something I particularly felt like doing, and nor did my collaborators. So we hired a bunch of summer students to do it, because that's a great summer job, right? You come in the morning, you inject the rats, you go play tennis or basketball or something back at night. So the first student who did it, in full disclosure, happened to have been my cousin, who's now a world famous scientist in his own right.
Oh.
But it's important to know that he was my cousin because he called me at midnight at home. And I don't think another student would have had the courage to do that. And he said, I don't know what I've done wrong. I'm really terribly sorry. My basketball game went late and I arrived 2 hours late and all the rats are dying.
Oh.
So I thought, oh, I better do a house call on these rats.
No.
Well, it wasn't all of them. It was only the rats that were usually completely resistant to any inflammatory disease. And he asked me, how can you explain that? And we're walking down the halls at NIH at midnight and the fluorescent lights in these long halls. I'm trying to figure out how am I going to explain this? And I realized that the drug we were giving was an experimental drug that had been developed for high blood pressure. And a lot was known about how it affected the brain. And it was known that it blocked the brain's stress center, the hypothalamus. Mm-hmm. I should tell you, this drug was not put on the market. Our studies showed that
it shouldn't be on
this drug. And maybe what that drug was doing was preventing the brain's stress center from giving them, the rats, their own shot of cortisone when they needed it to protect them from that septic shock. So that observation made me hypothesize that the brain's stress center is important in susceptibility to autoimmune inflammatory disease. Mm-hmm. And I said, maybe the reason the other rats get autoimmune inflammatory disease so easily is they have a blunted hypothalamic pituitary adrenal axis stress response, and they're not putting out enough cortisol. So why did they survive when we gave them a drug that blocked the brain stress center? They'd already found a way around it, and they had backup systems. So they didn't need that. Well, there was nothing for us to block with them. Whereas the Fisher rats, they had a potent, and this is what we discovered when we went back and did the endocrine workup on these rats, that in fact, the Lewis rats, the highly susceptible to inflammatory disease Lewis rats, had a blunted, almost non-existent hypothalamic pituitary adrenal axis response to anything, to stress, to, whatever we gave them. And they behaved like laid-back California rats. That's what we used to call them, the laid-back California rats. They didn't care. You put them in a new cage. They went to sleep. They couldn't care less. The Fisher rats, the high stress, had a hyper responsive hypothalamic pituitary adrenal axis response, a hyper responsive stress response. And they had hyper responsive stress behaviors. When you put them in a new cage, they started just sort of grooming, running around, chasing their tail. They were very anxious rats. And so that was really a crucial observation that connected in a whole animal system a blunted brain stress response to a tendency to higher autoimmune inflammatory disease. And then we did a whole bunch of studies to prove it, and did hypothalamic transplants in the two rats, and we corrected things, and we blocked the hypothalamus in the Fisher rats and made them more susceptible, and so on. But it was that single observation combined with three pieces of information that I had in my brain. That young woman who'd gone into septic shock and knowing that you need glucocorticoids to treat it. The knowing that drug affected the brain's stress center. And the third thing is I had been working with Candace Pert, who was at NIH, and she, you may recall, was one of the discoverers of the opioid receptor in the brain. And at the time, she was doing studies looking at interleukin-1 receptors in the brain. And I had seen the brain sections of animals, of rats and mice, where she was able to show that there were indeed interleukin-1 receptors in the region of the hypothalamus. So that connected all the dots for me. I said, well, maybe what's happening is when you're in septic shock, you're releasing these immune molecules. They trigger these centers in the brain stress center to then release cortisol eventually from the adrenal glands that then shuts off inflammation and prevents you from going into septic shock. So it all became clear by putting these three pieces of information together.
Wow, that's an incredible story. That my brain's gonna have to wrap my head around all that, because that is pretty amazing. I think just the series of experiences you had that led again to that formulation of that in that moment. It's really interesting.
Let me add something to that. I want to interrupt you because for students, this is really, really important. I thought, well, this is so obvious to me. It should be obvious to everybody. But no. You are the only one who has had your particular set of experiences that allows you to have certain insights that nobody else is going to have. And it may be obvious to you, but it may not be obvious to anybody else. So go with your gut and go with your instinct. And so that's one thing. And the other thing is, when we write papers backwards, right? We start off with a hypothesis. We say, I hypothesize that the brain and the immune system connected with each other. Well, I did not. I mean, I sort of did. I was looking for that connection, but I didn't hypothesize that the hypothalamus had anything to do with the immune system or with arthritis. I didn't know what had it to do with it. But that observation allowed me to create the hypothesis that the problem was in the hypothalamus. And then I could do the studies that proved it.
Yeah, that's fascinating. I'm going to divert us so that we make sure we talk a little about, your work, your focused work today. And, you just mentioned this concept of how, one's own personal experiences is what shapes them. It's, yours is different than mine, is different than everybody else's. And we might be in the same room and come up with two totally different perspectives on what's happening because of our own personal experience. And so my own personal experience, and one of the reasons I was really interested to talk to you, and I'm just interested in your work, is I suffer from a little stress in my life. And, it's, I'm sure, genetic. I'm sure it's due to a job that is demanding and sort of nonstop. It is just my human nature. And so, I know, from the point that you've just described and all of these things that you've learned, some of the focus of your work today is really on how stress makes us sick, how stress keeps us, from being well and living our best life, not only just making us sick, but living a good life. And then how sort of the biological mechanisms of that intersect with the space that we're in, the space, the physical space, the environment that we are in. So I would love to hear a little bit about, where you are in that today, how can a place make me, a stressful person, well? How can it make me feel better? How can it make me have a better experience in my life?
Well, that came from another set of experiences.
I led you a lot. I skipped a lot of steps. I know.
Yeah. So it was a combination of personal experiences with stress and with arthritis, and I'll get to that in a moment, and a single question that was asked to me by the then director of research of the U.S. General Services Administration. It's the agency of the federal government that builds and operates all non-military federal buildings for over 1 million office workers across the United States and around the world. Your libraries, your courthouses, your embassies, any federal building that's not military is operated by the GSA and built and designed by the GSA. So I was a scientist at the intramural research program at NIH, and Kevin Campshire, who was then research director at the GSA, asked me to help him gather the data to prove that the built environment can actually affect people, the occupants, the workers, happiness, sort of stress, relaxation response, mood, health, and ultimately productivity. And in order to design the spaces to optimize their health, well-being, and productivity. And he wanted the hard data. He needed the hard data to convince the powers that be that they should spend more money to build a beautiful building like the one in your background there. But, back then, that was the early 2000s, certainly in the late 1990s, 1980s. The spaces that people worked in were tended to be high wall cubicles, poor ventilation, loud mechanical noise, no sunlight, no windows. And he wanted to know how to design the spaces so people would be happy, healthy, and productive. And so we started working on using wearable devices to measure the impacts of the built environment on these health outcomes. But before that, my own personal experience in the mid 1990s, I was under a lot of stress. My mother was dying of breast cancer. I was a long distance caregiver. I was under a lot of stress at work. And I developed inflammatory arthritis. So here I was 9 years earlier. I had discovered the importance of the brain's stress center in arthritis in rats. And then I become, a poster child for what I had discovered. And I moved into a new house in Washington, D.C. And my neighbors were Greek, and they knocked on the door and they saw me writing what was to become my first book. And I've told this story many times before. But so they asked me, "Are you a writer?" And I said, "Well, I don't know. I don't think of myself as a writer. Why do you ask?" And they said, "We've always wanted a writer to stay at our cottage in Crete." So I said, "Okay, I'm a writer."
Right.
And so I went with them to Crete, and just for a couple of weeks. And I had, at that time, my arthritis was pretty bad. And I had gone into NIH. I'd plugged myself into an NIH early arthritis protocol. I'd had knee biopsies. I'd had a whole workup. And I was supposed to go back into hospital to get a liver biopsy and experimental drug treatment for this arthritis. But I was so exhausted from hospital, and from my mother had just died. And I said, "No, I'm not going to do that. I'll delay, and I'm going to go to Greece instead." And I went with them to Crete. And it wasn't a miracle cure, but in the period when I was there, I began to walk every day. I was swimming in the ocean every day. I was eating a healthy Greek diet, Mediterranean diet, we call it. It's fresh vegetables, fresh fish that the fishermen were, hauling out of the ocean that morning. Lots of fruits, and I would climb to the top of the hill above the village, which had the ruins of a temple to Asclepius, the god, the Greek god of healing. And I'd sit there for hours and just look at the Mediterranean, the blue, blue, blue Mediterranean, and the white stucco buildings and the fuchsia bougainvillea. And I'd inhale deeply, and I'd listen to the sounds of the sheep and the goats. I didn't know I was meditating. I have learned since that I was meditating. I thought I was contemplating, but I was in the moment. And so all of these things, the support of my neighbors, of the other villagers, we know now those are all aspects of integrative health. I was practicing all those, what the Andrew Weil Center for Integrative Medicine calls the 7 core areas of integrative health. I was sleeping well, sometimes under the stars on the roof of their tiny little cottage. And so that really, I was able to understand at an intellectual level, when I made the discovery about the brain and the immune system in the rats, that the stress response has something to do with the immune system. I never really fully understood it at a visceral level until I went through it myself. And when I went back to Washington and I saw my rheumatologist, I went back and looked at the notes in his chart. He said, "She's so much better, she doesn't need to go into hospital." So, it's not that I had a miracle cure, but I realized that if I continued on the path I was before I went to Greece, eating cheeseburgers and French fries every day for lunch, having a sedentary life, being stressed in many ways, I would continue to be sick. And if I purposefully, consciously changed my life to do the things I was doing in Greece, then I would get better. And that's what happened. So going back to the GSA and the studies on the office space. So we did find in our first study, which we published in 2010, of office workers in a we did find in our first study that we published in 2010 that office workers in a retrofitted Denver office building were significantly less stressed on two measures of the stress response, salivary cortisol and heart rate variability. So the hormonal stress response and the neuronal stress response. They were significantly less stressed in the new, light, airy, beautiful, open office space with views to the mountains, with low mechanical noise, with good airflow, compared to when they were in, or when others were in, the old space that had high 6-foot high cubicles, was dark, it was musty, it had high mechanical noise. I don't know why I was surprised.
Right.
I think the reason we were surprised, or I was surprised, I was so used to working in these terrible spaces that I didn't pay attention to it anymore. And again, it's only when you see the difference that you realize, wow, that was awful, Yeah. And so we continued after I came to the University of Arizona. So Andy Weil, Dr. Andrew Weil and Victoria Mazes recruited me to come to the University of Arizona. And, it was a hard decision to make, to leave NIH. I grew up in Montreal, I'm an East Coast girl, and I never envisioned that I would live in the desert. But when I saw Tucson and the beauty of Tucson and the mountains, it's a city in a bowl of mountains, and the beauty of the Sonoran Desert, the fragrances of the desert after the rain. I mean, all of it is just so beautiful. And most important was the amazing Center for Integrative Medicine and the team there, and how committed they are to training the next generation of physicians, all generations of physicians, in integrative health, and to think about health as much more than the absence of disease. And so that was really important to me. And that allowed me to bring together this research on the environment, which is a very complex experience, and what I was doing at the molecular and immune system level, and to really think about the person not only as a brain floating in the ether connected to a bunch of immune cells, which is how I used to, my PowerPoint talks always showed a brain and then a bunch of immune cells. And it left out the rest of the person. It left out the people that people are interacting with. It left out the physical environment that you're in. And all of that is essential to physical health and emotional well-being. And, so being at the University of Arizona with people, and this is where Bio5 comes in as well, being able to collaborate across disciplines is just remarkable. It's not easy to do. University of Arizona has a lot of infrastructure that allows one to, not only allows, it fosters interdisciplinary cross-college collaboration. So I have very close, and now I've been here 10 years, collaborations with the College of Engineering, certainly the College of Architecture, Planning and Landscape Architecture, College of Science, Department of Psychology, College of Agriculture and Life Sciences, and on and on. And it is just so exciting to be able to work with all these people who have knowledge and disciplines that I don't know anything about. I don't know anything about systems and industrial engineering, or mechanical and aeronautical engineering, or architecture and planning and landscape architecture. I'm learning about it all, but I'm working with people who are really expert in these domains. And it allows one to create these research projects that can tease apart these very complex interactions that lead to either illness or health.
Yeah, I mean, I think as a non-scientist that is fortunate enough to be able to hear and help share the stories of the work of so many incredible scientists, researcher, physician, engineers, that's the common theme. And I feel so fortunate to be in a place like Bio5, where that's just embedded. And as you said, and as I've learned over, I actually have just been here 10 years too. And I think I remember when I started right around the same time you did. I remember that. But I've learned that it's not really that common even today, and at U of A and in spaces like Bio5, and it is just something we value here. And I think it's just it's really incredible to see everybody come together and just work around these really complex things that will make a big difference in people's lives. And I love to be able to help tell that story because it's very important. And I would love to talk to you forever. We will have you back. Do you have anything really exciting coming around the corner? Are you just continuing on with other, really important things you're working on, or is there anything exciting?
In terms of exciting things that are coming down the pike, the Andrew Weil Center for Integrative Medicine is building a new building. So
that's right. Yeah.
Look down the street.
Yep.
From where you are, just sort of catty corner from the Health Science Innovation Building, and literally across the street from Bio5.
Yeah.
You can see the ground being dug up. I think the footings are already in. What's so exciting about that is with an advisory committee with faculty and the dean of the College of Architecture, Planning, and Landscape Architecture, experts in sustainability, experts in landscape architecture, experts in architecture, and with my colleagues from the U.S. General Services Administration advising also on sustainability and post-COVID reentry, which we didn't talk about that at all, but that's a huge issue in the office space question. Yes. And I'm going to say one more thing. I know we're going on a little long, but I want to say one more thing about that. But in terms of the new building, we had these wonderful advisors working with this amazing architecture firm, Line and Space, and the architects created not just one building, but 3 buildings that really embody the mind, the body, and the spirit. And it will be an oasis. It will be a destination for people across the campus, across the community, around the world to visit and see how you actually embody integrative health in a physical structure. And, you can go to the Andrew Weil Center for Integrative Medicine website and check out the new building and the webcam and the progress on the building. And it's supposed to be ready, I think, the end of 2023. So one more thing I do want to say about COVID. For 2 years, we got used to working at home, right? There's upsides and downsides to that. There's, quarantining, that's great. There's flexibility. There's loneliness. There's lack of ability to work with people and connectedness. And now going back to the office space, so many people around the world are doing this hybrid thing of working from home and going back to the office space. You need to remember that your susceptibility to getting sick from a virus depends on 3 things. 1, your exposure to the virus, the dose of the exposure, the duration of the exposure, and the 3rd thing is your resilience. Good ventilation systems, masking, distancing, filtration of the air, being outside, dilution of the virus, all that helps reduce your dose and duration of exposure. But your resilience is something you can do something about. And integrative medicine and integrative health and those 7 core areas of integrative health that the Andrew Weil Center for Integrative Medicine has defined can help you optimize your own resilience. It doesn't mean you won't get sick. It doesn't mean you're going to be protected totally from getting sick, but it will allow you to optimally prevent yourself from getting sicker than you might. So resilience is really important. And I would recommend that you provide in the materials associated with this, the My Wellness Coach app. The center developed an app that came out, was launched in February 2020. And so we released it for free in March of 2020 when resilience was so important. And it can help walk you through those 7 core areas of health: sleep, resilience, movement, social interaction, spirituality, nutrition, and the environment, and see which one you need to tweak to optimize your own resilience and protect you from getting too sick.
Well, we could not end on a better note. Thank you for that, for just your ongoing work in this area. That's so important for everyone. And you know, especially as we sit in this you know, academic university environment with our students who have gone through, you know, this you know, unimaginable curve of their life that no one could have predicted or anticipated or even had any idea how to deal with. And now they're being, as you said, pushed back into the real world, and it looks totally different and feels totally different. And I think those tips are so important for us all going forward. And I think we'll probably inform a lot of decision making going forward, I hope, about just, again, resiliency and how we achieve that, both biologically and with our environment. And I think your work is so important in that. So thank you for spending time with us today and for all you do. And we will have you back again soon. And I look forward to talking about what's coming up next.
Thank you so much. It's been a pleasure.
All right. Well, thank you so much. We'll talk to you later.
Okay. Bye-bye.
All right. Bye-bye.
Thanks to our listeners for tuning in to another episode of Science Talks. Continue the conversation with us next time as we learn more about the amazing science happening at the University of Arizona's Bio 5 Institute.